Welcome to EnerVista Flex Toolsuite training module. In this module, we're going to cover these topics. Overview. First, we'll introduce what is EnerVista Flex. Log into EnerVista Flex, and here we'll enumerate the default user roles and password, commonly used preference settings, and the role management of different levels login users. In Quick Connect, we are going to use a USB cable to do a quick connect and show you how to troubleshoot in case the quick connect fails. Under Device Monitor, we're going to introduce various commands, device status, measurement, records, test simulation, and virtual inputs. Project creation. We're going to create a project with substation, voltage, bay, and device, and then import the project. Setting files. This will be the most important part of this training video. We'll show you how to download and upload the setting files, how to export as CL file such as CID, ICD, or IID, etc. Logic. In this session is about the Flex logic within the PSL Programmable Scheme Logic Editor and the relevant virtual outputs. Records. And here we'll see some events and commutator disturbance records. And last not least, IEC 61850 configuration. We're going to briefly show you the interface of the IEC 61850 configuration tool, how to map the external CID to the remote inputs of the P40 Agile Enhanced GGIO5. So now let's get started. The ICT IED configuration tool used for P40 Agile Enhanced is called EnerVista Flex. It can be used not only for the configuration of the P40 Agile Enhanced, but also for the GE Reason MU640 merging unit. In the future, it will support more GE IEDs. EnerVista Flex Toolsuite can be set into 3 languages, English, French, and Spanish, before each start of the software. When connected to P40 Agile Enhanced, the device can also be set in 3 languages. For the HMI, if connected with the MU640, then only English is available for the device language. After installation of the EnerVista Flex, we can double-click the shortcut icon on the desktop and click Yes to continue to start this software. EnerVista Flex, and by default you get the guest username. There are different other roles we can choose. One is administrator, and we're going to log in with administrator roles. The username is ADMIN. We have other roles: engineer, operator, guest, and cybersecurity. For all the other roles except the guest, the password is welcome123, and we can click I to see the password 123. So that's for all the roles except the guest. The guest username is guest, uppercase G, G-U-E-S-T, and the password is guest1234. So we're going to log in as administrator, and from here, as we said, there's 3 languages. We're going to select language English, and this is only the language for the software interface. There's another setting for the device language later in the device, and that depends on if that device supporting multiple languages. So click Login. This is the dashboard landing. From here, you can go to the projects or start the Quick Connect. We're in this default, the dark predicts color, and the first thing, if you want to change that color preference. We have this my preference setting, appearance. If you don't like this dark color, we can change it to a light blue, light green. So for this demo, I'm going to using the light blue. And for the other settings, we have the setting preference, allows you to change the communication settings in the offline device. That's for the IP address. That's one option you can choose. Another is the polling read, how often you're polling the reading in the measurement. By default 3 seconds. That means if you have a current injection test set injecting to the relay, you have to wait for at least 3 seconds to see the metered values updated in the software on the screen. And the range is minimum is 1 second and maximum is 60 seconds. So that's for the preference setting. We save this one, so that means I'm keep on using this light blue color. And the next is about. Click about. You can know this is the version 1 and released on May 26, year 2020. And under admin, you can choose the user profile management. The first thing is you can edit the profile, and you can insert your picture by clicking the edit profile, and browse image. You can set a picture, but the picture must set the dimension between the 50 to 200 pixel. You can do this one in the Microsoft Paint, and here you can select the different roles, the cybersecurity, the operator, engineer, and here you can change the default password into your own password. And also only the administrator can manage these different roles. And there's another roles to tells you what you can do. The engineers, what operators, for example, operator get a very limited function, quick connect, computer settings, online parameter, etc. And that's the introduction part of how we log into the EnerVista for the first time and how you change some settings. Now we're going to do a quick connect with a USB cable. For the quick connect, we have to use a type A to type B USB cable, and sometimes we call this a printer USB cable. And on the software, under the modules, you can see the project, then the quick connect. We can click this quick connect button, or there's a small quick connect button here on the right side. We can also click this small one. Once we click, it opens the quick connect dialog box. You can see the default IP address, slave address, and port numbers. This information can be confirmed from the relay front panel. So now we're going to try click read model number, so we can see that the order code is read. That means communication between the relay and software is working, and now we just click connect. And now we can see that it's changed into the green color, that is connected. We can further continue from here to log into the device. If you see the connection failed message box, first check the USB cable is plugged into the relay. Then you can go to a folder called under the C drive program file, power management, and EnerVista RNDIS. There's a troubleshooting guide PDF. You can read following that procedure to check what's the problem. Or if you don't see a network under the network properties, you can run this bridge RNDIS setup again, or you can just run this USB troubleshooter exe file, automatically fix this one. There's also a manual way to fix this one. Is you go to open the network settings under the network adapters. We can see this Ethernet 2 GERNDS device. If you click this one, click the property, and under this TCP IPv4, you'll see that the IP address being set into the 192.16.0.9, which is on the same subnet with the relay, but the last octet is different. So this one, if you see this not set into that IP address, if it's set into the opt-in IP automatically, you can manually fix this one by clicking this use this IP address by typing 172.16.0 and 9, or any number other than 3. So click this one, and usually that should have fixed this problem. So that's how we can manually fix this connection if you got a connection fail message box. Okay, so now from here, if you move the cursor, you can see that there's a firmware update button. If in the future, if you want to upgrade the firmware, just click here and get the firmware file and do the firmware update. And then we can click this go to device view, and from here you need another authentication for the different levels. From here, this is the different roles. First time we see from the software login, this is the device levels. We got this observer, administrator, engineer, operator. If we for this demo, we're going to log in as administrator, but this time the password is not welcome123, and the password is 0. Again, you can click I to see this password. That's password 0 for the device. And now you click, and now you have access to the relay. This is the live mode, and what's the difference is that you can see the monitor. This monitor and the user configuration, these two tabs are only available when you connect online to the device. So far, we are talking about the regular order code of the P40 Agile Enhanced. If the order code has advanced cybersecurity, then the password will be different. So let's do a quick connect with another relay of the cybersecurity order code. Click read order code, and we can see that this order code has 4B, which means it has the advanced cybersecurity. So now click connect, and then we go to connect to device. We'll see something different than the regular order code. Instead, you see the pull down list. This one has a blank bracket. You have to manually type in administrator. And for the password, it's not 0 anymore, but change me one hashtag. And you have to use capital C and M. So it's change me one hashtag. And you can click the I to just to display this password. And now click connect. So now the relay is connected with this advanced cybersecurity order code, and this is the password you have to use later when you're trying to upload the setting files, and for any access to the relay monitoring, etc. So it be the same password for all the advanced cybersecurity order code P40 Agile. Now we logged into the relay on the online mode. We can have this monitor tab available. So from here we have commands on the top. With this command you can do the reset of the target message. You can clear records or select the records. You can reboot the relay, manually trigger the waveform capture, and clear the last trip data. At the bottom, you got device status, measurement, records, testing, and virtual input. From the device status, under the information, main CPU, you can see that really the firmware versions, the order code, serial number, MAC address, and of course you can see the different status of the opto input, contact input, relay inputs, virtual inputs, etc. So if you click this one, you open a new tab, output input, relay outputs, virtual inputs, and virtual outputs. Every time we open one status, we're generating a tab on the top, so you can switching back and forth to see the different status. In case if you want to see that both the information, for example, the virtual inputs, outputs together, so you can do a drag down to show this into a separate window. So now we have a separate window open for this virtual output. Let's wait for this become wider. Okay, so this is the virtual output status. We can drag this virtual input down same way. So now we can see this both virtual inputs and outputs parallel. We can see the status. Same way we can open multiple windows and put them parallel. So that's for the device setup. We can check the communication. Later when we do this 61850, we can check the goose status. We can check the clock, Eric B. For the measurement, we can see that the current and voltage. Again, as I mentioned, that we can drag them down to show the two separate display. Now, actually, I'm using the single-phase current injection test set injected into the relay. I can see I got 40 volts injected. And I can see my current is 5 amps. I can using the knob to control that the magnitude of the voltage and the current. So now they are reduced a little bit. All the parameter can be dragged into a separate window to be displayed simultaneously. And under the record, we can see that the circuit breaker status and the digital counter. And under the testing, this is very useful information. We can do a three-phase current simulated mode without having a test set. So under the pre-fault, we already preset 60 volts, 120 degrees apart, minus 120 stands for the lagging of the 120 degrees for the voltage, minus 240 for the phase C. We got current set 5 times the CT. CT depends on your selection under the system. Phase angle minus 30 degrees to the voltage, the reference angle. So under the setup, you can simulate the different stages. So we can simulate the pre-fault, fault, and the parameters since the pre-fault is being set already. So now we can click save. Now the parameter is being saved. So now we should be able to check this parameter from the relay front panel. And also we can see this from the metered display. If we go back into the metered three-phase current, voltage, we can see that simulated being applied in both the front panel and this metered screen. And the last one is the virtual input. We're going to introduce more about virtual input in the following modules, but for now this is just the command where you can execute on and off virtual input. But the prerequisite is that you have to enable the virtual input first before you can operate this one. We're going to introduce how to enable this one in the following training module. So that's the introduction part of this monitoring function of the videos. Another tab is the user configuration. This is only available also when you're doing the online mode. Later we're going to see that you get other tabs available in the offline setting file, but this is the user configuration. You can define the roles of the administrator, the engineer, and the operator. You can set your own password and different roles for the different functions. This one you can define yours. Now we're going to create a project from scratch with the substation, voltage, bay, and device. Under the modules, click a project. We can see there's a default MU640 sample and P40 Agile Enhanced Sample 2 projects created by the guest. So we're going to create a new project. Click the top new project button and give a name. I call this project LD. Make sure you're using this underscore instead of the space for the name. Create a project, highlights the project name. On this topology side, click this AND substation. We're going to end this substation name. I'll call this Markham. Click OK. Then highlight Markham, clicking this lightning to ending a voltage. So I call this voltage 69 kV. And now actually you can drag this substation box and voltage box to the middle. And again, from the voltage you can end in the bay. So I'd call this bay 650. And then click this bay and the device. From device you can choose 640 or P40 Agile. I'm going to choose P40 Agile, and I'm going to create a offline setting file without having a device. And I will make this device match into the relay I have for now. So for the order code P14D, the next one I'm going to choose L. Then next one I'm going to choose 2 sensitive earth fault. I'm going to choose 5 EIA R485. Then next I'm going to choose D 11 inputs. The next I'm 3 for the 61850 DMP3 Modbus and 103. Then the next I'm going to choose B40AE Flex. So all the rest will be matched into my relay. So I click OK. Now a new device is created under the project. And for this project we can save it for now. And this project can be exported into the a backup archive. So highlight the project name and click export, and you can give this a name. Let me just put this into the desktop called the project LD. So now this is exported. So now if you want to import this back, for example the backup, of course better you rename it, otherwise software asks you to rename it. So now you have a project. Actually, import project SCD. Okay, so you can select this project. And import, which give you a automatic rename _1, because this is just a demo. This is just to show you how you import a project. Yeah, so we got a backup project. Of course, you can drag this the box. So this is how you created a project and backup a project. A nice thing to under this project is another feature we can have is associate this offline setting file with a device. So click this. Let's save this project for now.
There's another way to create a project by using the drag and drop from the device toolbox. The project can also be backed up as a TS zip file with a smaller size than a CD file. Now I'm going to create a new project with the same project name, substation, by using this toolbox. So now the project is created by using the drag and drop from the toolbox side. So now I can save this project. Okay, so going back to the project name, the list, we can back up this project into a different format is the TS zip file. Click the checkbox for the project LD and click this export. So now we can export this into a TS zip file and click save. So now we have a smaller sized TS zip file. If we want to import the TS zip file, just click import button and click here. Now we have a same name, we have to rename it. So we can rename this just into 1. Okay, so this project is imported, project LD1. You got exactly the same structure, the IDs. So this is how we have a second way to create a project by using the toolbox and also backup into a different format, a TS zip file. And now I'm going to continue from the first project.
So click this associate button, and you can disassociate with 122.16.03. Okay, you got a serial number mismatch. You can continue, and from here you can switch between the offline to the online mode. Once you see this online turned into the green, the device changed from the yellow to green. So now if you double click this offline device, you have exactly the same interface like Quick Connect. You have access to the monitor, that all the functions under the monitor. So that's something you can do under the project and associate this offline setting file. Use the associate button to make this into the online control mode. So that's I'm going to switch back into the offline again. So that's the demo of how we create a project, how to back up a project, import the project, and how we can associate an offline setting file within a physical relay. Now we come to the most interesting part of this training video, is how to download the setting file, write a setting file to the relay, and how to export this setting file into a different format. So from the topology, we can highlight a bay level, and from the right side, the toolbar, you can have a quick download button is available. So that means you can do a quick download, and this will generate a new file under that the bay level, so adding a new device. So once this complete, you just click here, and this finish button will be available for your click. And now you have to select this where you want to save this file. Now this file is saved in a hidden folder in the PC. You have to select where you want to put this in the project. So let me choose this under project 650. Okay, let's select this again. So now AE_2 is generated because the first one is called the 40AE. So now this have a new setting file is created. So that's for the first way, is you click a quick download. There's another way you can click. The second button is called receive CID. If you highlight this device name and click receive CID, it will just update the setting file, the content of that CID, without creating a new device name under the bay. Again, click here and click finish. So now this a new setting file is downloaded here. It's updated internally, but you don't create a new device under the bay. So that's the difference between this quick download and receive CID. Now, if you made some changes, you want to upload this setting back into relay, you can click this send CID. Again, this will send this, it asks the password, 0 for administrator, continue. So now file transfer, this will send the CID back into the relay. So that's what we can do here under the project topology. Once you see this one is finished, okay, you have to wait and click. Yeah, so now click finish. So this is the read and write on this toolbar. If you just double click this open, and you will notice that under the device profile, the very bottom right, you got two icons, receive CID and send CID. So by clicking this receive CID, you will do the same action of the receiving CID, or you can make some changes in this screen and upload this setting file. The difference is that here you only made some internal change. You change this relay, send this back into relay, but you just have no access to the setting file. So for people who want to know where is the setting file saved, so there's one way you can do is highlight this device and click export. Be careful, this export the same button, but now because you're highlighting the device, so now you're exporting a setting file instead of the project. Okay, so this one. Okay, we have to save this project first. Export. So now it asks you where you want to save this file. Now you can create your own folder. For example, I created my setting file folder. I created the P40AE. I can call this Markham CID. By default, it's saved as a CID file. Again, this allows you to give the other options. You can save it as a ICD file used for the SCT. Or you can save it as an IID file, instantiated file, or SCD file. So for here, I just using the default CID file. So now you saved one setting file to your local computer specific location, specific folder, which you know you want to archive the setting file from this project topology. Under the project topology, we can compare the setting files. If you highlight one device setting file and right-click mouse, you can choose compare. You can compare with default, across project, with external device file. If I choose this one and do a comparison with another file, Bilbao. So I can see that I got the difference in the file 1 and the file 2. The path saved a different file. That's the default file location. Then I got the order code, the version number, and you can see the settings. When you see that the highlighted color, you will see the difference. So for example, the Ethernet, just to show you one quick example, the IP address are different, disturbance are different. Let's see the CT ratio. So one is 1000, one is 10. So from here, you can see the highlighted part. You know there's a difference between the two setting files. To close this one. Under the device, we can go into the from here. You can see that the device language. This is a different with the previous software language interface, and you can choose this different language here. And if you go to that the settings open, you will have another export. This export is something different with the project export. So from here, if you, for example, this is the give you the access to the settings, the CTVT, whatever system inputs. If you click this export, it gives you 4 formats: XReal, that's for the Omicron test set, PDF, CSV, Excel. And why there's no CID option here? Because as we know that for the SCL language, it has a private domain, public domain. So this is the setting part is mostly about the private domain of this setting file. So that's you can only export in this 4 formats: real file, PDF, CSV, and Excel. Okay, so that's the introduction of this setting files. You know that we have different ways to download the setting file, upload setting file. You can export into your local drive specific folder with the different extensions, CID, ICD, RID. And then you can also choose the profile and also make this export the setting file into the 4 different formats. So that concludes this setting file demo part. Now we're going to briefly introduce the PSL editor by using another setting file, the Bilbao demo setting file. Under the profile, we click this logic. We're going to open this PSL, Programmable Scheme Logic Editor. So all this pull down list of the flex operands, you see this can be used in this editor. And now you're opening one of the default logic. You can just scroll up and down to see what being used. So this being multiple protection element assigned to the virtual output. See this starting with the VO1, VO8. When you're using the virtual output, one thing you need to be careful is that certain virtual output are reserved. If you, for example, 128, if you click this 128, try to use it, it will pop up a message says VO114 to 128 are reserved for virtual output contact, for the contact outputs and for the LEDs. So do not use this virtual output. Try to use from 1 to 113 for your protection in your logic. And for example, this LED 5 to 8 will use one of these preserved virtual output. So that's just a brief introduction of this virtual outputs, and we'll get a more detailed introduction of this flex operand virtual PSL editor, how to use this virtual outputs, and in another training modules 106. So you can close this here, and you will see a compiled lines of the logic, and you can see that LED5 got one assigned VO128. Now you see the 27. So that's the preserved virtual output used for the LED and output relay. Okay, so that's the part for the logic introduction.
There are two ways to retrieve the records in the offline mode and online mode. First, we'll introduce from the offline mode by using the refresh button. So from the offline setting, we can see this records, and click this records. We have a refresh button. After clicking this refresh button, we have a save events and DR file message box. So from here we need to connect into the relay. So by clicking the continue, we have to log in administrator and enter the password, change me one hashtag, and click continue. So now the events and disturbance records have been downloaded. We see this receiving. Once we see this successfully completed, we just click this finish button. And now we can see this events and target. Later in the online mode, we'll show you how to save this into your local drive. But the difference with online and offline mode, this is your connecting to the relay only when you're required, and in the online mode is always continuous communicating with the relay.
We're starting from this project online mode. As we said, if you see this device turned into the green color, you can double click this online device and enter the password. You have the same as in the Quick Connect online. So from here, we click records. We're going to open the records, for example, the events and oscillography. Okay, from here, we see the top one is the EVT, that's events. We can double click this view. We can see what events happened to this device. And we can close this events and go to the open the COM treat. So we can first view the summary of this first COM treat. So we can see what's where data is saved, what the parameters, and this is the view the waveform. So we can see the waveform with the current, we can see the values, phasor, we can see the digital inputs. We can know this is the phase, TOC, pickup, start. Again, we're going to introduce more about this events and oscillography in the next 103 videos. For this one, we can use the filter function just to select, for example, only the events or events and the com trait. So I can apply this filter, and you can also export, select this certain events and oscillography, export into your local drive. So again, I'm going to create a temporary new folder on the desktop, EVT oscillography. So now this port being exported into the desktop. If I go to the desktop and check this folder, so we can see that the events folder, which is under a Word file, Notepad, and also we have this a com trait format data file with the CFG, with the data, with the header for the com trait. Okay, so that's the brief introduction of this the records. We'll have a more detailed introduction, especially how we can preset triggering of the com trait, the waveform, in the next 103 training video. Now we're going to briefly introduce the IEC 61850 configurator. In order to do this demo, we're going to import one external CID file from the URL. So click this import, we select the URL CID file, click open. Now we have to select this project for this URL to be saved under the base 650, and click this file and import this into 650. So now click import, we can see that a new URL file is saved under the base 650 with the P40 Agile. So click save this project again, and we're going to open the drag this URL parallel with the device, and we're going to open this 61850 configurator under device. We can see here we got the dataset creation. We can create a dataset, and we have this logic device, master, protection, control, and metering. We can choose that different logic nodes under the master protection. For the metering, we got the metered MMXU, for example. So that's the logic nodes under different logic device. We also have this control block. Once you set a data set, you can use this control block. Okay, so now this is nothing set yet. Then the report control block for the MMS. We got a sample value control block, but that's only for the MU640, not for the P40 Agile Enhanced. All this part, we're going to have a more detailed introduction in the modules 107, including the GGIO1 to GGIO6, how to set up these GGIOs. And here we're just introduce how you can map this into the remote input. So this UR published 3 goose message of the control push button. So from here we can select the 3 corresponding remote input under the GGIO5. We can select this status indication 1 to 3 status values and drag. So this is the goose 1, goose 2, goose 3, and subscribed by this GGL5 from the P40 Agile Enhanced, and you can save it. And if you want to remap them, you can want to disconnect this. You can click this unmap. So unmap, you remove that one. Or there's another option under the device. You right-click mouse. From here, you have one called Unmap All Subscriptions. Again, there will be a more detailed introduction for this part. This is just a very brief overview for the 61850. We have more detailed introduction for this part in the module 107. Now let's recap what we learned in this module. First, we introduced what is EnerVista Flex, what kind of GEIEDs it can support for the configuration. In the login to the software, we listed different roles and the default password, and the preference settings like the colors and the polling rate, etc. In the Quick Connect, we use the default USB IP address 172.16.0.3 and made the quick connection between the computer and the relay without installing the data model. You should know now how to troubleshoot in case the connection fails. And don't forget to check the front panel USB IP address to make sure that it was not changed. Under Device Monitor, there are various commands like reset, clear records, and reboot the relays. And under Device Status, we can check the opto inputs, contact outputs, virtual inputs, remote inputs, outputs, etc. In the measurement, we can see the metered values, and which can be also dragged to display the multiple metered values. And then we can see the records, the test simulation of the three-phase current voltage without using a test set. Then the virtual inputs command. Under the project creation, we know how to create a project with a substation, voltage, bay, and device, and how to export, then import the project. It's very important to back up your project file periodically. Under project, we can also import external CID files like UR, 8 series, or MyCom P40 Agile. Under setting files, we demonstrated two ways of download and upload the setting file under topology view and under the device. When under the topology view, you can choose the quick download and receive the CID. The later one will not create a new file within the project. If you want to save the setting file to a specific folder on the PC, then that file can be exported to SCL files such as CID, ICD, or IID under the project topology. Logic. We introduced the PSL editor for the Flex Logic. Now we know that virtual output 114 to virtual output 128 are reserved for the contact outputs and LEDs. On the records, we showed some events and COM tree disturbance records. And now we can know to use the filter to select only the events or only the disturbance records. And last, in IEC 61850 configuration, we briefly showed the interface of these configuration tools, demonstrated how to map the UR file to the remote inputs GGL5 of the P40 Agile Enhanced. That concludes this training videos of EnerVista Flex. Thanks for watching.